In this lesson, we'll finish our discussion of learning target number 2. How can you determine the number of particles, moles, or mass of a chemical sample given another of these values? Also, being able to convert from one type of particle to another. Here are the math equations that we've learned so far in the unit. Now you're going to come up against questions that involve all three equations combined together. An example would be if you have 10 grams of carbon dioxide gas, how many oxygen atoms are there in the sample? In order to answer the question, I would first use equation 3 to change my 10 grams into moles of CO2. Then I could use equation 2 to change my moles of CO2 into molecules of CO2. Then I would use my conversion factor equation number 1 to change molecules of CO2 into oxygen atoms. Now, some people may find this difficult, solving using one equation and then subbing in your answer into another equation. So the mole map was created to show visually in a diagram how these math equations are related together. If you're comfortable using equations, just go ahead and use them, but pay attention to how the mole map was created and how it works as well, just in case you decide to use it later. You are allowed to use the mole map on quizzes and tests in grade 11. The version of the mole map we're going to use is this one right here. We have different mole maps for each unit, so make sure the one you're using says Unit 3. And we're just going to use the top one for now. It shows the second and third equation that we've learned. It places the terms in boxes and rearranges the equations and shows you what you have to do to move from one box to another using arrows. For example, if I want to figure out the number of particles a sample has, big N, I would take the moles, little n, and times it by Avogadro's number. Or if I want to do the reverse and have particles and want moles, I would divide by Avogadro's number. The same thing is shown for the mass conversion. If I want to determine the mass of a sample, I take the moles in my sample and times by the molar mass. Or I can take the mass in grams divided by the molar mass of the chemical to determine how many moles it has. The only thing it doesn't show is how to convert from one type of particle to another. Notice that all three types of particles are in the same box. So if you want to switch from molecules to atoms or formula units to ions, you would need to use the times want over have in order to change one particle into another. Remember my example? If you've got 10 grams of CO2, how many oxygen atoms are there in the sample? Using the mole map, it tells us what to do. We're going to start here in the mass box because that's what's given to us in the question. I can divide the 10 grams of CO2 by the molar mass of CO2 to get it into moles, and then times it by Avogadro's number to get it into molecules of CO2. Now I know I'm in molecules because CO2 is a molecular compound. The question asked me for atoms though, so notice that it's in the same box. I need to use a times want over have conversion factor in order to answer the question. Try out the particle to mass conversion questions on your assignment cover sheet. Some of these questions you might get stuck on. The main common problem is that people lose track of what chemical or unit you're in and stop before you actually answer the question. Make sure if you've got a question where it's one chemical and you're asked for a different chemical or a different particle, you include in your solution a conversion factor.